Hello friends, thank you for taking your time and your interest in this topic. In this video, I'm going to share with you the step-by-step procedure of calculating CCME Water Quality Index using Microsoft Excel. Okay, so in general, any researcher dealing with water quality monitoring and assessment will surely come across CCME Water Quality Index. But for the first few attempts, most of the researcher will find CCME Water Quality Index a really hard nut to crack. However, I can assure you that after watching this video, you will be able to crack CCME Water Quality Index calculation. And you might even find CCME Water Quality Index interesting, and you will be able to do the calculation by yourself, and you might even implement it in converting your water quality analytical data in your study into a data or value easily comprehend or understand by the general public. But before we kick into the calculation part, first let us see in brief about the CCME Water Quality Index. CCME stands for the Canadian Council of Ministers of the Environment, and the Water Quality Index method developed by the Canadian Council of Ministers of the Environment is called the CCME Water Quality Index. And this was published in the year 2001 and contained the guidelines for assessing the water quality of any area or sources. So since the inception of the Water Quality Index, there are a number of water quality index methods which has been developed and employed in water quality assessment. And CCME Water Quality Index is one of the many. Many researchers from all across the globe have implemented CCME Water Quality Index in their study. And these are a few papers that have been published with respect to water quality assessment using CCME Water Quality Index. Okay, so like any other water quality index method, the purpose of CCME WQI is to convert the water analytical data into a single data or value which will finally represent the overall water quality of an area studied. However, before arriving to that single value data in CCME Water Quality Index, we have to first calculate the value of these three elements of CCME WQI, and they are F1, F2, and F3. F1 is the scope, F2 is frequency, and F3 is the amplitude. And to calculate these three elements, we have to use the formula given by CCME Water Quality Index. These are the formula and steps that we need to follow meticulously while doing the calculation of CCME Water Quality Index. Okay, so there are three steps. Step one is you have to calculate the F1 value or the scope value. Step two, you have to calculate the frequency value or the F2 value. And then step three is you have to calculate the amplitude value or the F3 value. And in step three, there are three sub-steps. Again, you have to calculate the excursion value, the normalized sum excursion value, and then finally the F3 value. And after that, you calculate the overall CME WQI value. Okay. So for practical purposes, let us assume that I have collected water samples from three different sampling stations. That is sampling station 1, sampling station 2, and sampling station 3. And to determine the change in water quality with time, samples were collected and analyzed seasonally, that is during winter season, pre-monsoon season, and post-monsoon season. For all these water samples collected, 10 parameters were selected for the study. And these parameters are pH, electrical conductivity, turbidity, total alkalinity, total hardness, calcium, magnesium, sulfate, chloride, and BOD. Okay. So for carrying out the CCME Water Quality Index calculation, all selected parameters should have a standard limit, without which this parameter cannot be incorporated in the WQI calculation. Okay. So for station 1, these are the analytical data of all the parameters analyzed during the 3 seasons sampling seasons. Okay, similarly, these are the analytical data for all the 3 seasons for all the parameters. Similarly for station 3. Okay, so looking at this data, now if you look at this data, the researcher might find it hard to conclude what type of water quality does station 1 or station 2 or station 3 possesses. So this question can be answered by using CCME Water Quality Index. And at the end of the calculation, a single value will be obtained for station 1, station 2, and station 3. And this value will be any number between 0 to 100. Then, accordingly, the 3 values obtained for all the 3 different sampling stations will fall in one of these 5 classes. And then based on that, the water quality of the sampling station can be determined or known. Okay. So let's start with sampling station 1. Okay. Before you start the calculation part, make sure you arrange your data in this format. Okay. Put the parameters in this first row, the standard limits in the second row. Okay. And then you put the analytical data in the third, fourth, and fifth row. Okay. First of all, we have to copy the analytical data from station 1. Okay, so I copy this, I go to this sheet. Okay, and then what I have to do is go to paste spatial, go to click value, and then click transpose because it will be arranged in transpose position. And then this is the data here. All right. Okay. Now, after you inserted the analytical data in this worksheet for station 1, okay, now this is how it will appear. Okay, so the next step is the most important and crucial step before calculation part. Okay, now after this you have to check. What you have to do is one by one for each parameter, check if the analytical data of each parameter for each sampling season cross the standard limit or not. If the analytical data cross the standard limit, then highlight the cell with red color for easy identification. Okay, the permissible limit for pH is 8.5, so all the values are within the limit, so it's okay. You have to move now. You have to move to the next parameters. The permissible limit for electrical conductivity is 300, but all the values you find here, they are exceeding the permissible limit. So what you have to do is just highlight them in red. You'll know why later on. Okay, I'll use this. Would be easier. Okay. Now similarly, now check for turbidity. Turbidity permissible limit is 5. Now what is the value of all the for all sampling season? You'll find that throughout all sampling season, the turbidity limit exceeded the permissible limit. So in that case, you just highlight it with red. Okay. Now what about total alkalinity? Total alkalinity permissible limit is 200. And all the value is within 200, so you don't have to mark it red. Keep it as it is. Okay. Next, total hardness. For total hardness, you'll find that during winter season, it exceeded, so you just mark it red. Here it is within, so no need. Here it again exceeded, so mark it with red. Okay. Similarly for calcium, here, permissible limit is 75, and 146 is more than 105, so it exceeded. It exceeded the permissible limit, so you mark it as a red. Here also, mark is red because exceeding the permissible limit. 122.23 is also exceeding the permissible limit. Now, how about magnesium? Magnesium 30 is the permissible limit, and all the value are below 30, so no need to mark. And sulfate permissible limit is 200, and for all sampling season is more than 200. Mark is at red like this. Okay. Now chloride 200 is the permissible limit, and all the data you'll see is very low, so no need. Similarly for BOD 5 is permissible limit. Now all this is in. So now once you're done with this, all the data which are highlighted with red color cell here are the one which exceeded the permissible limit. Now once you have done this, then you are ready to proceed into the calculation part. Okay, For simplification, I've made this framework where you just have to insert a value and use the formula to calculate the F1, F2, F3 and the CCME WQI value. Okay. Now based on this, we will start our calculation process. Okay. Now first thing first, before we start the calculation part, to make it easy for you, according to CCME Water Quality Index, when you say variables, you're referring to the parameters studied. And when you say objective, you're referring to the standard limits. When you're referring to the number of failed variables, it means the number of parameters which exceeded the standard limit. And when you refer to when you say total number of variables, it means or refer to the total number of parameters studied. When you say total number of tests in CCME Water Quality Index, it means that, let's say, if you have 12 water parameters are studied, and for 2 sampling season, then the number of tests will be 12 into 2, which is equal to 24. And in our example that I give you, we have 10 parameters, we studied 10 parameters and 3 different sampling seasons, so it will be 10 into 3, which is total number of tests will be 30. Okay. Before I start the calculation part, let me again briefly reflect what I just have done. First, the analytical data from station 1 are copied and then are inserted here. First step. Next step is you have to cross-check are the analytical data exceeding the permissible limit or not. And if they exceeded the permissible limit, you highlight them in red color. Like so. First, let's see what is it. What do you mean by the number of failed variables? Number of failed variables is the number of parameters in the study exceeding the permissible limit. Okay. So now have a look into all these 10 parameters that you study, how many parameters exceeded the permissible limit? The one which are marked with red. So EC exceeded the permissible limit, filterability, total hardness, calcium, and sulfate. These are the parameters which exceeded the permissible limit. So how many parameters are there? 1, 2, 3, 4, and 5. So your X value will be 5. Okay. Next will be the total number of variables. When you say total number of variables, mean the total number of parameters studied. How many parameters do we study here? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the answer here will be 10. Okay, so total number of variables or the total number of parameters studied is 10. Now, how many tests are there? Total number of tests. Total number of tests is, in our case, in this example, okay, the case there are 3 season and 10 parameters. So 10 into 3 will be 30. So the total number of tests will be 30. Okay. Next, we'll see what is the total number of failed tests. When you say the total number of failed tests, it means all the analytical readings which are marked with red color. Okay, so how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the E value would be 1 for 14. So the total number of failed tests is 14 for station 1. Okay. Now once you get this value, you get this number of failed variables value, total number of variables studied, total number of tests, and total number of failed tests. Then the only thing you have to do next is you just have to insert these value in the formula, and then you will be able to calculate the or find out the F1, F2, F3, and CCME Water Quality Index. Okay. So first, let us calculate the F1 value. What is the F1 value or the scope value? So F1 or scope is of all the parameters studied, how many parameters exceeded the standard limit. Okay, so it can be determined by using this formula here. So the formula is number of failed variables divided by total number of variables into 100. Okay, so this is the box that I created here. Okay, so let's see what's the F1 value. Just give equal sign. What's the number of field variables? Number of field variables is the x. So just click the value here and divide it by total number of variables. Total number of variables is 10. Okay, so 10. You divide it by 100 and then press enter key. You'll get 50. Okay, let me change this color. Okay, now let's calculate the F2 value. Of all the parameters today, how many times all the parameters exceeded the standard limit? And it can be determined by using the formula here. Number of failed tests by the total number of tests into 100. So F2. To find out F2 value, just put equal sign. What's the number of failed tests? Number of failed tests is, total number of failed tests is E. E, which is 14. Just put this, click there, divided by the total number of tests. Total number of tests is that. That is here. 30 into 100. So that's simple, isn't it? So from here you already got, just from these value here, you can find your F1 and your F2 value. Now we have to calculate the F3 value. Okay. So for calculating the F3 value, there are 3 steps, sub-steps. Okay. First, you have to calculate the excursion value. So what is the excursion value? In the excursion value is the number of time by which an individual concentration is greater than or less than the standard limit. So in simple word, it is the analytical value exceeding the standard limit. So what are the fail values here? The fail values are these 14 values, isn't it? So what you have to do is you have to copy all these values one by one. Okay, so first I'll copy this for EC. Okay, phase spatial, because I need to arrange them in horizontal way. So see. So what's the standard limit for EC? Is 300. So objective, as I told you earlier, objective when you say CCME, it means standard limit. So the value here will be 300. Okay, so we put 300 in all these 3 values here. And next, copy the field value test of turbidity. Now you copy the same way, phase spatial, value, transpose. Now what's the permissible limit or the objective value? The objective is 5, or the standard limit is 5. 5, 5, and 5. See. Now, what next? Next is total hardness. You copy this for value here, phase spatial, value. Okay, 482, and again you copy this phase spatial value. Okay, what is the permissible limit of hardness? 300. So you type here 300. Okay, next, this one, next is for calcium. Calcium all sampling season. So what you do is copy, paste spatial, put the value and transpose. Okay, what's the permissible limit? 75. The objective will be 75, 75, and 75. Okay, and lastly will be the sulfate. Okay, so sulfate will be again a spatial value, transpose. Okay, and then standard limit is 200. So type 200 for objective. I made it this way so that it will be easy for you to calculate instead of doing one by one. Okay, now you have got all the false value. You see, to calculate the excursion value, you have to get the field test value. So we have got the field test value. All this one mark in red, I place it here. Okay, in this row. And then the objective value, objective is the standard limit. Objective is standard limit, so the standard limit also are inserted. So I have got A and B. So what I have to do next is I just have to divide A, which is the false failed test value, divided by the objective or the standard limit, which is in this cell. Okay. Enter key. Now you'll get the A divided by B, which is this part of the equation. Now I just have to drag it for the rest. See, I've got all the values here. Okay. Now, what's the last part of the excursion value? Excursion value here says field test divided by objective minus 1. So I'll do the same. Okay. So here, see, I've got the A divided by B, which is this. Now, what I have to do is just put equal sign. A divided by B minus 1. Now press enter key. Now this will get this value here. So what you have done is you have calculated the excursion value of all the fail variables. Now from here, for the excursion value, let me just minimize it a little bit to make it visible. Okay, so for the excursion value, you have to do the summation of all the fail variables. So what I have to do is I have to go to auto sum, press enter key. Okay, so you'll get this value here and mark it with highlighted like this. It will be visible for you. Then once you have completed this, now you see that in the next stage, which is the normalized sum equation, you need the summation of excursion value. So the summation of excursion values you have already calculated. So this is the one. Okay. So now, once you have calculated excursion value, so see the NSE value or the normalized sum excursion value is summation of excursion value by total number of tests. So the summation of C we have already calculated. So what I have to do, just put your equal sign here. Summation of C, which is the excursion value, which is this, isn't it? Then you divide it by Z. What is Z? Total number of tests. Total number of tests is here. So just click here. Now you'll get this normalized sum excursion value, which is 1.5805. Okay. Now last step of F3 will be you have to calculate the F3 value. What is NSE? NSE we already calculated, which is this. So just copy this, paste it in the NSE value like I've done prepared here. Okay. Now see the numerator is NSE value. Denominator is 0.01 NSE plus 0.01. So to make it easy, I've done it this way. So put equal sign here. 0.01. Okay, as per this formula here into NSE. What is NSE? This is the value of NSE. Now I've got the value of this. I've got this part for the formula. Next, what I have to do is the 0.01 into NSE, which is this value, plus the 0.01. 0.01. See 0.01 here. Now I've got this. Now after getting this, now only I can calculate the F3 value. What is F3 value? F3 is NSE. NSE values this much. This or this same, isn't it? Then you divide it by this value, the new denominator value, which is this. So your F3 value is 61.2479. Okay. Now you have calculated the F1 value, F2 value, and F3. And last will be for calculating the CCME Water Quality Index. And you have to use this formula. Okay. So I've made this procedure will be easier for you. Just follow my steps here. So what is the F1 value first? F1 value is 50 and F2 value is 46.66. So what you have to do is just put it here. 50 is the F1 value. 46.66 is the F2 value. And what's F3 value? F3 value is 61.247. Okay, you have got all the F1, F2, and F3. But if you have a look here, formula F1 square, F2 square, and F3 square. So what I have to do to make it easy, so I just put an equal sign. F1 into F1, that will be square. So 50 square of 50 is 2500. Similarly for the other two of F2 and F3. Now you have got this value. Next stage is you move or you do or you calculate the or you take the sum values. Go to auto sum, you add them. Then you get that this will be the sum value of F1, F2, and F3. Okay. But if you have a look carefully, this sum value here, okay, is under square root. So what I have to do is I have to get the square root value of this sum value. So what I have to do is put equal sign and type SQRT. You see this function here, SQRT. Click on this and click on the sum value, close the bracket, and that will be your square root value of this sum value. And now you have to divide, you see you have to divide this this value, which is 91.809 by 173. So what I have to do is very simple. Next is calculation only. So square root, which is this divided by 1732. 1732. What's the value you got? 53.007 is this value here. Okay, from this equation, this part of the equation is 53. So now you put this 53.007 value here. Okay, now what you have done, you have got this part, you have got this part. Next is the last stage, which is the 100 minus this, and 46.99 is your 46.99 is the CCME Water Quality Index of Station 1. Okay, so in order to save time, I have already calculated the CCME Water Quality Index for Station 2 and Station 3. All right. So the calculation process for F1, F2, F3, and CCME WQI is the same. The only difference is the number of fail variables and the number of fail tests. Okay. For example, if you see here, Station 2, the number of fail variables is 1, 2, 3, and 4. So see 4 number of fail variables. Okay, the one I highlight in red. As the number of failed tests will be 1, 2, 3, 4, 5. So 5 here. So this will be the same, and this also will be the same. Okay. So similarly, you go to Station 3. In Station 3, you will find that all the water parameters are within the permissible limits. See, 300, except only this, which is 11, exceeding the 5. And the rest, have a look, it's all within the permissible limit. Okay. And the number of failed variables for Station 3 is 1. The number of variables, this will be the same, this will be the same for all. The number of failed tests will also be 1. Okay, so based on this, CCME Water Quality Index value. For sampling Station 1, the CCME WQI is 46.99. For sampling Station 2, the CCME Water Quality Index value is 70.50. And for Station 3, it's 93.51. Okay, so now let's go to result part. So now after getting all the CCME Water Quality Index value, now you see Station 1, 46.99 falls under this class, meaning that the water is marginal, under marginal category. Station 2, 70.5 will be here, which means the water is fair in quality according to CCME Water Quality Index. And Station 2, the CCME value is 93.51, which is that the water falls under this category. Okay, so with this, I hope this video will help you in how to calculate the CCME Water Quality Index. And these are the references that I mentioned in the video. So with this, I hope that you all will find this video helpful. So once again, thank you so much for all the support in my previous Water Quality Index video. Thank you for your mail and for your compliment. And I hope this video will also do the same. So once again, thank you so much for your attention, and God blessed.